So guys, I'm Mathias. I'm the original author and lead developer of Spray, and I'm glad to be having the opportunity today to introduce you to the project in this talk. I've got quite a lot of material to cover, so I hope we'll get to some questions at the end. If not, feel free to approach me at any time. I'm going to be around today and tomorrow as well. Yeah, let's dive right in. What is Spray? How many of you have actually had anything to do with Spray so far? Excellent, excellent, cool. So we call it a suite of libraries for building and consuming RESTful web services on top of Akka. It says it all, actually. It was first released about a year ago, right after the Akka 1.0 release, and we needed it for our own purposes because we had a Akka 1.0 application that needed to go into production in summer last year, and we were looking around for something like Spray, couldn't find anything, and just basically started to scratch our own itch, like so many libraries. And here we are a year later, 4 releases later, and we're quite happy with the reception and the positive reactions we got so far. So there are a few principles that guide our development here. First, we want something that's lightweight, right? Lightweight, few dependencies. It's built on Akka, so it's fully asynchronous, non-blocking, actor-based. That's it. We wanted to have it modular. That's why it's a suite of libraries, because we want you to only depend on the ones that you actually need and not just pull in a huge block of monolithic something, right? And of course, it needs to be testable. Our philosophy, it's a library rather than a framework, right? Initially, we weren't quite clear on that distinction, but we have eradicated all mentioning of the words framework from the documentation just to make this clear. We're going to get to that in a little bit. So as a suite, it contains of a few components. One of the important ones is it's got a rich, immutable HTTP model, which is actually based on the one by the Blue Eyes team. So kudos to the Blue Eyes team for letting us use that and starting this, because it's great. It has one component, the central component of this talk, which is Spray Server, which is a DSL for the server-side construction of REST APIs. There's also a complementary HTTP client, which works with the same model, with the same abstractions, and it's actually quite nice in many situations when you have a client as well as a server working with the same things, because it makes lots of things easier, like proxying or a few things. Maybe we get to one example later on in the talk. There's also something that we didn't have from the beginning on, which is called SprayCan. It's a very thin layer, no dependencies HTTP server, also built on Akka as the only dependency apart from Scala. What this gives you is basically, it lets you use Spray with outside of an servlet container, and it gives you a nice few other things like asynchronous response and request processing, which you can't do with a servlet container because the API doesn't support it. And then finally, there's yet another Scala JSON implementation that you can use. There are many of them out there. This one is type class based, actually originated from SJSON that you might know. It's very clean, nothing much to say. That actually doesn't depend on Akka as the only component. So let's double click on Spray Server. That's basically, as I said, it runs on servlet containers or on SprayCan. The servlet containers it supports are basically all the 3.0 API compatible servlet containers. You can also use Jetty 7 or Tomcat 6 if you are stuck on these old ones and still need to support them. Basically, all we need is some way of asynchronously processing the request. As I said, it's a tool for building a self-contained API layer. We're going to get to that in a second, what that means. A central element is a routing DSL for defining the behavior that you want. And the focus is web APIs, not web GUIs, right? This is a clear distinction. From the beginning on, it was clear we wanted to build something that is focused on the API side. So we don't really see Spray as in the same space as Play or Lift or something, just because it's focused clearly on APIs. We're going to see that in a second when we talk about the basic architecture that we have in mind when you build something or we use Spray. Like, let's say you have an application. You have an application that you build, has your business logic in there. You build it using the tools that you want. So you use your build tool, your middleware layer, probably Akka, maybe not. We don't affect this way. We don't affect in any way how you build your application. That's your application, and it should be in the way that you want it. Now, say you want to put a REST API layer on the side, right? So you want to somehow connect it with the rest of the world through a REST layer. I've drawn this on the side on purpose, not underneath, because we don't want you to get the notion that you build your application on top of Spray. You don't. You build your application on top of whatever you build your application, and you put in Spray on the side. So what happens when a request comes in? This is an actor message actually coming in from the servlet container or from SprayCan. It hits the API layer, and the API layer is going to probably, in the interesting cases, trigger some kind of action in your application. This is also a message. Now, the key point here is that this action is a domain object. It should be something that's defined in the context of your application, right? It shouldn't be JSON, it shouldn't be XML, it shouldn't be something that's got anything to do with HTTP. You define on the business level what this action is, and it's the responsibility of the API layer to do this translation and lifting in the level of abstraction, right? Now, when your application answers, it's going to come back. Maybe it doesn't have to, but sometimes or many times it comes back with a reply. And this reply as well is a domain object, right? And again, it's the REST API layer that actually then translates this down to an HTTP response. So this is the architecture that you have to have in mind when you want to build something cleanly. The advantage of doing it this way is that your application is completely decoupled, right? And you can swap out, should something better come along, your API layer against unfiltered or Blue Eyes or whatever, but your application stands as it is. Contrast this with a web GUI application, like a real web application. Yeah? That's what we mean when we talk about web applications. You would be building it with Play or Lift or something, but you're going to be very tightly integrated with the framework that you use. And it makes sense for Play to be a framework and give you much more structure than Spray does, because the center point of your application, if it's a web application, is going to be the interface, right? Here, it's not. Your application is some big service, and this is just an API layer. So the API layer has certain responsibilities. You want to discriminate between different requests based on the HTTP method, the path, the query parameters, the content of the request, and so on. And obviously, you need to treat one request this way and another one another way. And this routing is something that's the responsibility of the API layer. Then, as I said, you need to lift or decrease the level of abstraction by marshalling or unmarshalling to and from your domain objects. Encoding, decoding, compression is something that should happen in the API layer that your application shouldn't be worried about. Authentication is something that should be happening there. Maybe the API layer needs to talk to your application to authenticate. Maybe it doesn't. Depends. Still, it's living in the API layer. Then you might want to do some caching. You might want to serve a little bit of static content. That should certainly be possible if you have some documentation or something. It's nice if you can do this. And obviously, since we're trying to be RESTful here, it's important that the API layer supports you or does it properly, the error handling. You want the right HTTP status error codes coming back. And since we're talking about an API, you're going to have clients. And in many cases, you might want to have a public API, and your clients are going to be some kind of whatever, consumers. And having proper error messages that really are helpful, that tell the guys what went wrong and how to fix it, is crucial in building a product that's actually appealing to the outside. So this is an important point. Now, let's look at an example of what it might look like if you build something like a route or some kind of API definition with Spray. This is just a very simple example. And without telling you much more of how exactly it works, you should be able to figure out what happens here. Like it's quite readable. You can see it, right? Basically, we have two different ways of completing this request. One for GET requests, one for PUT requests. And there's a certain path that's going to be matched. So it's very straightforward. Let's look at how this actually works. So a route is the central point in Spray. And a route in Spray is nothing but an alias for a function type, which is request context to unit. Now, you might be wondering why this is unit and it doesn't return some kind of future. right? You could think, okay, maybe it should return a future on a response if it's asynchronous. That would certainly work as well. What we decided to do here is to use the explicit continuation passing style, which is basically equivalent. You can do most things that you can do with futures in this way and the other way around. There's certain pros and cons to the different choices. We consciously made the choice to go this way because it plays well with actors. And if someone has more questions on why we went this way, I'm happy to take it offline and discuss it with you. So the key point here, the key object is the request context that you can see. How you use it is basically it's a wrapper around the HTTP request, and it gives you all kinds of additional functionality like complete, for example. There are several overloads of a method called complete, and how you use it is the most simple route would be this one. You get the request context, you call complete on it, you're done. Basically, when you call complete, this is going to set off a whole chain of closures and functions that are going to be executing all the logic that needs to come after you applied your route this way to finally trigger the sending out of the response to the client. You can also write it this way if you want. Or you can use something called a directive in Spray, which is a building block in a route structure that is made up of all kinds of smaller chunks to build some complex behavior. So you could also just say complete with say hello or something, right? And the complete with, let's look at what it is. It's very simple. It basically just calls complete on the request context. And it also requires that the type that you use for completion actually has a marshaller associated with it. That's type class stuff that Seth just talked about, right? So let's go back to the example and dissect it a little bit. So the key point up here is the path directive. It's also a directive, right? It has a name, and it has a number of arguments. In this case, it's a mini DSL giving you a way of describing what kind of paths you want to match, right? So this is an order followed by some kind of integer, like an int number, but in hex notation. So what it does, it extracts something, right? It extracts the thing that was matched here, like the hex int number. Extracts means it basically, if a directive extracts something, it pulls out something from the request and makes it available to the inner route, which is something that you nest in there and that can work then with whatever you extracted. But it's itself, again, just another route. So it's just going on like this, deeper at deeper levels, and you can nest it arbitrarily deep as you want. So the inner route here basically consists of two parts, which are both routes again. So you have the get directive and the put directive, and they just filter based on HTTP method and pass it on to their inner route and so on. And what happens when you shoot a put request into this structure is basically the get directive is going to see it. It's going to decide, no, this one doesn't fit my filter. So I'm not going to pass it on into my inner route. I'm just going to reject it. And this little tilde there, this operator, basically just recovers from rejections, if you want. Like if the first route doesn't want to handle this request, then the next one chained in afterwards gets a chance to do it. If this one fits, all good. If it doesn't, then the whole request is going to fall through the whole structure, and it's not going to be handled by this thing. And Spray is going to take care that there's going to be a proper error message going back to the client. In this case, if you shoot a post request in there, the client is going to see post doesn't work. It's a 405 method not allowed error saying you can only do gets and puts here, right? You don't have to do anything. Spray is all going to take care of proper error messaging in this case. So when we step back and look at this thing, basically we see the whole structure forms a tree, right? A tree of routes that go on deeper and that have several branches. And a request flows through this structure in a depth-first manner up until a level where it gets either completed or rejected. And then it goes back and flows through the rest of the structure, right? So what we saw there basically still contained a little bit of repetition because it was in the get branch and in the put branch almost the same thing. You can dry it up like this if you just put them together. You can combine directives with the OR operator, which gives you another directive having the combined filter with an OR, right? So this is also going to work. Now, we needed to change the inside of this route a little bit because we wanted to get at the request method. So you can not use the complete with, but you just write it like this, and then the context gives you the way to actually get to the method. Now, what we can do here, you can actually pull this out. Now, you can make your own directive called get or put, which is a custom one that doesn't exist before, hasn't existed before, and you can just use that one, right? So that gives you a way of labeling pre-configured configurations of directives that make sense in your respect or in your application, and you can reuse it at several times. So if you have like a long, large construct, you can just use get or put if you wanted to. Now, if you look at what's left down there, you have a path directive, and nested inside you have the get or put. Basically, a request is only going to get to the very end of this route if both of these things match. The path needs to match and the method needs to match, right? And this you can also express differently if you use the AND operator, right? So rather, as an alternative to nesting, you can just pull those things together into one thing, which is also going to give you a directive, and then use this one. And once again, you can pull that out if you want. So now you have order, get, or put, what's something very specific in your case. So, and down the route there has become much easier to read. What this is supposed to show you is that it's possible to really work with the directives that you write yourself or that come with Spray to combine it into something that makes sense in your application and reuse it in complex structures, right? The point is that you can have really, really large descriptions of APIs that are still very readable because you just name them properly. Now, another nice aspect of these operators is that they are completely type safe. So let's look at what this means. Suppose we define this one, which is a directive that's just another name for a pre-configured path directive, right? What this does, it's a directive that pulls out, it extracts one int, as we've seen before. Now, this one obviously compiles. Let's try to make up this one. Like, we want to combine a directive that pulls out an int with one that just filters and doesn't pull out anything. So this doesn't work. You can't do this. This doesn't compile. Because what's going to be the common supertype of these two things? Right? So let's take another example. Let's say we try to combine the order path with a directive down there, which looks a bit strange. It has two elements. This is a regular expression combined with a double number, right? So this one, the rightmost side of this, pulls out two things. It pulls out a string that matched the regular expression and a double number, which is going to be converted to a double, right? And you can't combine that with an OR operator with a directive that just extracts an int. So this doesn't work. You can't do this. So Spray takes care, or the compiler takes care that you don't mess this up and that your structure properly works. So this one is going to work because you extract, again, you have a directive extracting an int, and the second thing also extract an int. What this thing does, it basically looks at the query parameter with the name order, and it makes sure that it can be converted to an int cleanly. And if it does, it pulls it out. So you have two different directives that both pull out an int, and you can OR them like this. So this works. Let's look at this. You have, again, the thing that pulls out an int, and you combine it with the AND operator with a directive that pulls out a string, so the value of the query parameter with the name OEM, and an option of string, which is the expired parameter that you might have in your request. The little question mark at the end basically says, okay, this is not required. You know, if it's not there, don't worry about it, and this automatically gives you an option. So you can use this, for example, in a route like this, where you say, okay, just apply this logic, and then give me the order ID, which is the int, the OEM, which is a string, and the expired, which is an option string. All right, let's move on. Spray comes with 69 predefined directives, so it's a whole lot. They do all kinds of things. They work with cookies, they work on header values, they change things about responses, they compress, decompress, whatever, right? We're not going to go through all of them. I just want to show you that there's lots of meat there for you to combine in whatever ways you want them. So rather than going through any of these in detail, I'm going to switch over to this, which is a real-world example. of what a spray route might look like in the wild. So don't worry about the boilerplate up there. That might change. Let's look at what's going on here. So anyway, okay, let's go through it one by one. So up here we have something saying encode response. So basically everything that's inside there is going to be compressed, is going to be gzip compressed. But it's not only going to be gzip compressed, it also makes sure that the request that comes in actually has accept encoding headers that match this, right? If the client doesn't accept gzip encoding, then this also just completes the request right away and says, you know, this is not going to work. You get a 406 unacceptable response with the information inside of the error message that you need to accept gzip. This is all packaged in this nice directive, so for you don't have to worry about it. So this thing here just defines the behavior of the root path. So if there's no further path down there, you just redirect to /doc. Very simple, and only get requests. So let's go down to the root path. No, to the doc. This is what's gonna hit if you shoot in a request to /doc. It actually, what it does on the inside here is it says get from resource directory. So it serves up static content that lives on your class path in some jars and underneath this path, and whatever is the subpath behind the path prefix is going to be taken out of the doc root underneath your class path structure. And then, because in this particular project, all this documentation actually was written in Markdown files. So what we need to do here, we basically do this, which looks complicated and probably should have been pulled out and named with a nice name. What it does, it transforms the response and converts Markdown to HTML. This thing here is defined in the context of this application that doesn't come with Spray. But someone wrote a function that changes Markdown to HTML, and you just apply it to this round like this. All right? So that's the /doc. Let's look at this guy. So if we have, that's the interesting bit, the API. What happens here? So we have one thing that says JSON-P with parameter. That's basically JSON-P support. Automatically already coming with Spray. Clearly, whatever is in here is a JSON API. So you want to give your clients the ability to use JSON-P, which is a special kind of JavaScript wrapper around JSON. And that's all you need to do in order to have this. Then, if you have the path /API/top articles, you go in here. It only responds to GET requests. It requires that there's a parameter that can be converted to an int. The parameter has to be named max. It makes sure that the max parameter is actually non-negative. Otherwise, you're going to get an error. And then the interesting bit is down here. This is a complete with, as we've seen before. And what it does, it takes the parameter max, wraps it in a message, sends it out to an actor, the top articles service, and this comes back with a future that is mapped to a sequence of articles. So your app, that's the call, the bridging call from your REST layer to your application, right? The top article service lives in your application. It expects you to send in a GET message, and it gives you back a list of articles. And this works just like this because there's a marshaller defined for this application that knows how to translate an article into JSON. And Spray helps you with things like Spray JSON support and so on to do that nicely, so you don't have to do a lot. But this is very readable and shows you exactly what this route is doing. So someone who doesn't know Spray or Scala can figure out what this thing does without any problem. So you see this path top articles. If it doesn't match, we're going to get down here. And there's something called token authenticate. That's a custom directive that someone using this application wrote. And what it does, it looks at a cookie and checks whether the cookie is there. And if it is, it's going to extract a user object out of somewhere, maybe by asking the database or whatever. But it makes sure that only authenticated requests actually get in here. So, and there are a few sub-routes like the ranking. This only responds to GET requests. There's a custom thing here that wraps this route with some logic that counts how often the user has used the API, how much time it's spent there, and so on. And then it extracts a bunch of query parameters, actually 5 query parameters here that are all of type int. Now, how do you see this? This question mark says if it's not there, then just supply the value that comes here, right? So it's an optional query parameter with a default value of 0. And just by writing this, Spray knows, okay, the type of this parameter needs to be an int, right? Otherwise, you couldn't have a 0 as a default value. So you extract 5 things. Usually, you would have to pick them up at the end, as we've seen. You would have to pick them up individually as 5 different parameters. Now, that can become a bit clunky in your route definition. So Spray gives you the ability to just say, okay, wrap it up in a case class, like this one. If we actually go there, it's a simple case class defined like this that has the different ints there, right? So this is case class support, automatic putting of extractions into case classes. And there's no reflection involved. This is all type class based. It's all type safe. It's fast, so you don't need to worry about it. You get a ranking descriptor, so it's an instance of this case class. And once again, you shoot it to your ranking service, map it to a result, and that's going to be used for completing the request, and so on. Right? There's more stuff here. We have a post. This requires that the user that was extracted up there is actually an admin, otherwise you can't do this. Then this actually extracts the content of the request. So it does the opposite of marshalling, unmarshalling, and it converts it to accounts details, whatever type that is, right? If it doesn't work, if there's any problem, the whole thing is going to create a proper error message that goes back to the client. And then once again, you have another service that is actually going to do the work in your application. You map the result, that's it. So you see how this works. This is just some stubs I put in here, so there might be more things where you have different routes for CRUD support, get, put, delete, whatever you want to have there, and so on. Here, we might have something like an old version of this that's still written in Python in some Django server. And if you use, it's also custom, but very easy to write. If you use Spray Client, you can just proxy requests back somewhere else, right? So you take the request here, you send it out as on the client side to the Django, and whatever comes back there just goes back and completes this route. Very easy to write, no problem with Spray. And down here, finally, we actually serve some static content, some CSS, some images. They live in, again, on the class path and public, are gzipped, and they're cached, and so on. So this is what I want you to take away from this is that you can have very complex definitions that are very readable, very easy to maintain, and you can understand what they do even half a year from now when you come back and look at the code because you need to fix something. Okay? So that was our real-world example. That's the real-world example again, just as a backup. Let me wrap this up. What are the best practices? Basically, best practice is you keep your route structure clean and readable, just similar to what we've seen so far. If you have a lot of logic, pull it out into custom directives so that you maintain a very clean structure that is easy to read. Don't let the API layer leak into your application, right? That should be separate. Stick to the clean architecture. This is easily done by just putting the API project or make it a separate sub-project underneath your common project that doesn't even have any dependency going back in, so there's nothing that your application can depend on. Use the unmarshalling infrastructure. It really helps keeping your routes clean, so don't do it yourself manually. Just decouple it. Use the marshalling in the type class-based way. There's blocking. Okay, let's not go there. And then if you use the Spray on SprayCan, you can use the cool plugin, the SBT Revolver plugin plus JRebel that gives you hot reloading. So you can have your application run all the time and just change bits. And as you change them, SBT is going to recompile the bits that are required, load them into your JVM, and you've got really fast turnaround. It's excellent. There's a lot of more stuff that I'm not going to be able to talk about today. There's support for LiftJSON, for Twirl, which is basically the play templating engine language that we pulled out and you can use in SBT outside of play. There's support for Scala T. There's asynchronous response push streaming that we haven't seen. If you use Spray on SprayCan, you can do that. There's stuff on testing, obviously, on how to customize the error messages. All that's possible. And we can talk about this maybe tomorrow if there's a workshop that you guys are interested. There's Spray Client, obviously, which has its own things. Current state, we just released the 09 release this morning. It's the last release for Akka 1x. We know that we're behind and Akka 2.0 is out and everyone wants to have it and use it and whatever, and we want to do it as well. So we're heavily focused on getting the first spray release out that's Akka 2.0 compatible. There are lots of coming features, even better documentation, better and so on and so on and so on. There are a few sprayers already. These companies all use spray in some way or another. There's a growing community. Just join the mailing list. It's very helpful. So follow us on Twitter. Thank you.